this record. All right. So today is going to be section 5.3. I believe we're going to get 5.4 done as well. We have class on Wednesday, but next week is in fact spring break.
Yeah.
Yeah, that's a good thing. Next week being spring break. All right, before we get started, I'm going to share my screen and I'm going to go to not share it just yet. I want to go to, now I want to go back and share it. Coming back. Share screen. Here. Okay, you know this. You've seen it 100 million times. No, not all of you, because you aren't getting this done. Assignment number 3, D2L Dropbox assignment. I had several zeros. I don't like giving zeros. Print it out now. It's due March 29th. Write on scrap paper and turn it in, or write on the actual paper and turn it in. Take pictures with your phone, whatever you need to do. But yeah, no, yeah, let's get it done. Okay, as you can see, you are to be working on homework 5.1 to 5.3 right now. On Wednesday, we will be covering 5.5 and into 5.6. And you notice it's not due till March 23rd. And again, that's because all of next week we are off with the spring break. But that doesn't mean you can't be still working on your homework and getting this Dropbox assignment started and working on that. And then again, the quiz isn't going to be till later. Kelsey.
I have a question. Do we have a date or an idea for the timeline of the midterm at all yet?
There is no midterm. Nope.
Oh, really?
Yeah.
Okay, cool.
Yeah. We just took a test the other day, but yeah, there's no midterm. Just a final.
Okay.
Yep.
Thank you.
No, you're welcome. Okay, section 5.3. Going to start out with a question. Does this, is the cosine distributed? Can I distribute just like I do, you know, if I had a 2 out front, can I distribute the cosine? And the quickest way to answer that is I'm going to turn on my calculator and I'm going to pick a cosine. Let me see if I can get this a little closer so you can see it. And let's say the cosine of 45 degrees. I better go back and make sure my mode is in degrees, because otherwise it's going to be crazy. And now I'm going to go back, and the cosine of 45 degrees plus 30 degrees. Okay, so I'm going to get that left side, and I want to know, is that going to equal the cosine of 45 and the cosine of 30? So does 0.258 does not equal. So yeah, that's not distributed. Quick example, I just picked 2 numbers, and the cosine of, this is 75, does not equal the cosine of 45 plus the cosine of 30. So one of the things to remember, the cosine of A plus B is not equal to cosine. So no, no, heck no, no, no with an exclamation point. So don't be trying to distribute that. Yes, question.
So we use cosine square plus sine square to find out should we use that for this one, this option?
Nope. What we're going to use is two new identities. 2 new identities. In fact, we're going to get 6 new identities before this day is out. Okay. The first 2, what does the cosine of a sum equal? The cosine of A plus B equals cosine first, cosine second, minus sine of the first, sine of the second. And thank goodness somebody went and proved that for us, so we don't have to do it. And real similar to that, the cosine of a difference is the cosine of the first, cosine of the second, but this time it's plus. So when I'm dealing with the cosine, my signs are opposite. Cosine of minus, and this is, so they're opposites. But the cosine becomes cosine of A, cosine of B minus sine of A, sine of B. And as I said, somebody went through and figured that out for us, and we don't need to walk through it. We just need to remember that it's not distributed. So now I'm going to get ready and say, okay, what is the exact value? Exact value. And this is something that happens over and over because people go, oh, just put it in my calculator. No, I don't want that. That's an approximation. It's a decimal approximation. So for this, I want the exact value. Somebody get me started. Somebody stop me. Oh no, that's the mask. Somebody get me started. I want to take this guy and rewrite it. How would I rewrite it? Well, I clearly have just learned these two new things. And I want to be able to rewrite it with cosines and sines that I know. Okay, that's great. So what if I said, what if I use this guy and instead of 15, I'm going to rewrite this as the cosine of, give me two numbers.
And
Stuff
5.
we know. Go ahead.
10 and 5.
10 and 5. Yeah, but I really don't know the cosine of 10. And I don't know the cosine of 5. But there are some that I do know. And they come from my special triangles. For example, go ahead.
I was gonna say 60 and 45.
Excellent. 60 degrees minus 45 degrees. Yep. Yep. Oh, yeah. So this is going to become cosine of the first, cosine of the second. This time it's plus, because the signs are opposite, sine of the first, sine of the second. Oh, yeah, buddy. Cosine of 60. Wonk, 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 wonk. 60, 30, 1 square root of 3, 2. So cut. You notice once again, we're building on something that we've learned before. The cosine of 60, adjacent over hypotenuse. Oh, I'm sorry. Adjacent, so it's going to become 1/2 times cosine of 45 degrees. I'm good at these. I've done these several times. 1 square root of 2. So the cosine of that is 1 over the square root of 2. My pages are sticking together. 1 over the square root of 2 plus sine of 60. Square root of 3 over 2.
Wouldn't 1 over the square root of 2 end up being the square root of 2 over 2?
Yeah, we're going to get to that in just a little bit. Yep, you're absolutely right. I'm just going to keep working here for a minute and then I'll switch that over. Everyone understand what he's saying? Instead of 1 over the square root of 2, why not now just put this in? And we could. Because when I rationalize it, I multiply numerator and denominator by square root of 2. Excellent point. Then the sine is 1 over the square root of 2. One over 2 square root of 2 plus square root of 3. Oh, you got, oh, that's not a 3. That sure looks like a 2 to me. Square root of 3 over 2 square root of 2. That's going to equal 1 plus square. Yeah, let's rationalize those first. This is going to be square root of 2 over Because if I multiply the top by square root of 2, I'm going to multiply the bottom by square root of 2. It looks like my denominator is going to be 6 million. No, 4. I'm going to multiply numerator and denominator by square root of 2. Looks like I get square root of 6 over 4 equals. Don't let this final answer trip you up. Don't let it trip you up. Final answer, square root of 2 plus the square root of 6 over 4. Yay. Oh. So the exact value for this is this. You put it in a calculator on the test. How many points do you get? Nada. 0. Nothing. All right, so far so good. If we were in a classroom, I would start calling on people. But Philip, hit me with the next one. Any clue what to do? Kelsey, jump on in. First of all, you say there's not a darn thing you can do because some dumbass wrote this down wrong. Because that's supposed to be the sign and that's supposed to be the sign. Here I am picking on students and it should be picking on me. Come on, man. Now does this look like something up above? Here I started with the left side and changed it into the right. Here I'm starting with the right side of the equation. I can change it into the left. Some of you are going, when will I ever use this? Well, you may be an engineer someday, and there may be you just never know.
Would you kind of just by working backwards add the 8793 to get 180?
Yep, because this is following that first one. So this is going to become the cosine of 180 because I added the 2. The left side says add that. Cosine of 180, yeah, I know cosine. There's pi. That's also 180, -1. Nicely done. Can I get an ah? Cool. Cool. You know, when today ends, we are halfway through this semester. The countdown is on. You know what else? I think we turn our clocks ahead on Saturday, don't we? Nobody knows?
Yes, yeah.
Yes.
Yeah.
Good. I was gonna say nobody knows. Co-functions. It's a good time to bring up these things called co-functions. And the co-function, if you think about it, here's the sign. Its co-function is the cosine. Is that where the name comes from? Maybe. From the cosine. And if you look, if this angle right here is 90, and this is theta, what's this angle in here become? Right there, right there. What's that become? Jump on in, give me an answer. Today, you're all getting a class participation grade.
Is it just 90 minus theta?
Absolutely. This is 90 minus theta. Yep. So if I said the sine, which is opposite over hypotenuse, if I said the cosine here, it's adjacent over the hypotenuse. So these two are in fact equal. And we now have the ability to prove that. Like if this was an identity, I would say prove this identity. And you'd be going, yeah, buddy, because I'd rewrite this as, let's see, this is the cosine of a difference. It's the cosine of the first, not too hard. Cosine of the second, Sine becomes opposite, so it's plus sine of the second, or sine of the first, sine of the second. Oh. If I peek back up here at my cosine graph, here's 90 degrees. So the cosine of 90 degrees is going to be 0 times the cosine of theta plus my sine graph goes up, and there's 180. So this is 9. Oh, that's 1. 1 times the sine of theta. Awesome sauce. That goes. This is in fact sine of theta. I verified that identity. Some great mathematician somewhere along the line said, yeah, I can prove this. I can dig it. Questions? Oh boy. The sine of theta equals the cosine of negative theta. What's theta? Quick hitter. Bam. I don't know. Yeah, you do. We just did. These guys are cofunctions. Sine of theta, 90 minus theta. What's theta?
Okay.
Yeah, I get the equation. 90 minus theta equals negative 30. This is true. So this is true. 90 minus theta equals negative 30. I'm going to subtract 90, get negative 120 degrees. Theta is 120 degrees. Oh. I hope no one's sitting there yawning. I hope y'all are excited as I am. Oh boy. Cofunctions again. Cofunctions again. The cotangent of theta equals the tangent of 90 minus theta. 90 minus theta equals 25 degrees. I'm going to bring the 25 over. I'm going to send the minus theta over. This side becomes a positive theta. This side becomes 65 degrees. The Bears. All right, I'm not hearing any questions, and you know the rules. If I don't hear anybody get comments, and then I must be doing a good pace, and I'm going to keep going. So now I'm going to pause. I have two problems. Pause. I'm going to pause. Play. Yes, it is. Here we go. Anybody not get the negative cosine of theta?
I got that answer.
What's that?
I got that answer.
Excellent. Excellent. Other people getting it? I hope so. Nobody
I
wants.
know.
Thomas Moscow has it. Yeah, Kelsey has it. Good, thank you. Alexander had it. Good. So I did cosine, cosine. This time it's plus. Sine, sine. Again, yeah. See, I do the graphs real quick because I know this goes up to 2 pi, which is 360. So if I want 80, I go to there for cosine. I go to there for sine. Quick hitters on how to find those values. Cosine of 180 is -1. Sine of 180 is 0. We're good there. Again, what else could we do? We could have drawn the unit circle, gotten to this point, which was -1, 0. And remember, this is the cosine, this is the sine. We used those values to build these graphs. But this was the cosine, this was the sine, that was the ordered pair. How many people got it? Anybody get an answer for the next one?
I think
was it?
Kelsey, go ahead.
oh no, I was just gonna say, I think I figured out like how to start it, but I have no idea where else to
Okay.
go from there.
Yeah, this was not easy the first time. This is also one of those, once you see it, most of you will go, oh, okay. Somebody else was speaking up. Was that you, Ethan?
Yeah, I was gonna say I couldn't read the bottom half of it because it was blurry on my screen.
Okay. Yeah, no, 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 no. Is that a little better?
Yeah, thank you.
Sine of theta is 3/5, and the cosine of alpha is -12/13. And I want you to calculate the cosine of theta plus the cosine of alpha. And as you know, let me try to get everything in right away. I could be writing this cosine theta, cosine alpha minus, because it's the opposite, sine theta, sine alpha. Okay, well, there's a little bit of a clue here when I say it's in quadrant 2, both of them. So first thing I needed to do was draw them. I'm gonna come back out just a little bit. Here we go. Theta is in quadrant 2. Its sine is 3/5. If I complete that triangle, you complete me. This becomes a -4. 4 squared plus 3 is 5 squared. Pythagorean triple. Well, that was kind of nice. Here's alpha. It's in quadrant 2. Its cosine is -12/13. And knowing my Pythagorean triples, bam, I get a 5 for the opposite. Now it's a matter of just looking at the graphs. Cosine of theta, -4/5. Cosine of alpha, -12/13. So yeah, I like them. Sine of theta, 3/5, opposite over hypotenuse. 5/13, opposite over hypotenuse. Now it's algebra time. -48/65 minus 15/65. Give you a second to copy that down. And now we have 2 more formulas or identities. We'll just keep adding all this stuff to our inventory. But the most important part is to understand how they work. This guy becomes this guy. Yeah. Okay. Well, section 5.4, once we do the cosine, which is considerably the easier of the two to start, these two kind of become easy. I see I have the sine of a sum, the sine of a difference. Sine of the first, cosine of the second. This time my operators are the same, plus the sine of the second, the cosine of the first. So this is sine and cosine, first and second, second and first. This is sine and cosine, first and second, second and first. Plus and plus, unlike the cosine where they're the opposite, the sine, they're the same. I don't know how you want to remember that. I should be in Slytherin. The sign of a difference is still a subtraction. So they're not so bad. The next one, yeah, it's one of those, the more you use it, the more you get it. Tangent of A plus B. Tangent of the first plus the tangent of the second, plus and plus, over 1 minus tan A tan B. Who in the world came up with this? tan A minus B. This time it's tan A minus tan B over 1 plus tan A tan B. My handwriting got pretty sloppy there. I think I was getting excited. Now, hopefully, as you do more and more of these formulas will become second nature and working with them will become a lot easier, but I have 4 problems. I have 4 problems, similar to like we did before. I'm hoping when you go in your groups, you're at least chatting with each other. Would be great if you had your screens on and could look at each other and laugh and even make fun of me. Again, this is the exact value. Don't be putting it in your calculator. So I'm going to give you about 5 minutes to work on these 4 problems. Let's start with the sign of 105. I rewrote it as 60 plus 45. Anybody else get the answer square root of 6 plus square root of 2 over 4?
Yeah.
Good, good, good. Sine of the first cosine of the second plus sine of the second cosine of the first. Boom. First thing I'd do when I take a test is I would write these down so I can just keep reference back. Might want to do that for the next test. The hard one. I don't like 7 pi over 12 so much. So I went and converted it and I got 105 again. Rewrote 105 as 60 and 45 and I got to this point and I thought, oh, I better wait for the class. So this is applying what we learned today. Now we're about to apply what we've learned this day. Then we're going to apply things we learned algebraically. The tangent of 60 degrees. Anybody know what that is? Tangent of 60. Opposite over adjacent. Square root of 3. Plus tangent of 45. Opposite over adjacent. That's 1.
1.
Over 1 minus, again, square root of 3 times 1. Times 1. So it looks like I have 1 plus the square root of 3 over 1 minus the square root of 3. Oh, happy day. I know how to get that out of there. I'm going to multiply the numerator and I'm back to algebra by the C word, Wordle, C word. Except it's that many letters.
Conjugate.
Yeah, the conjugate. I'm going to multiply top and bottom by the conjugate of this, which is 1 plus the square root of 3. 1 plus the square root of 3. I don't have a lot of room here, so I better be good. I get in the numerator a 1, a square root of 3 and a square root of 3. 1 banana and 1 banana is 2 bananas. Square root of 3 times the square root of 3 is just 3. Over 1, the outer and the inner cancel, minus 3. I didn't give myself so much room there. 1 minus, no. Numerator, 4 plus 2, square root of 3, over negative 2. Final answer. Negative 2 minus square root of 3. Did anybody get that? That would be awesome if you did. That would be awesome. Very good, Chow. Very good to all of those who did get this. That's putting today's with a couple of weeks ago with algebra from college algebra to get to that exact value. exact value. All right, the next two were simplify. Again, repetition. Sine of the first, cosine of the second, plus sine of the second, cosine of the first. Sine of the first, cosine of the second, plus sine of the second, cosine of the first. I get something that looks like that. Not much more to do with it right now, but that's what I got. Tangent of the first minus tangent of the second, minus and minus over 1 plus tan first, tan second. Tangent of 45 luckily is 1, so I get something that looks like that. 1 minus tangent of theta over 1 plus tangent of theta. Okay, hopefully in your groups you got to do a lot of that. Let's see if I'm going to do these two, see what happens. Sine of A equals 4/5 in quadrant 2. All right, so in quadrant 2, here's A. The sine is going to be 4/5. B is in quadrant 3. And it's -5 over 13. -5, B is adjacent, -5 over 13. Sine of A equals 4/5 in quadrant 2. Bam. Cosine of B equals -5/13 in quadrant 3. Bam. Pythagorean triples. 3, 4, 5. That's one of my Pythagorean triples. Here's another one. 5, 12, 13. 25 and 144 equals 169. By location, this is a -3 and up 4. -5, this has to be a -12. So the first thing I need to do is draw those triangles. This becomes sine of the first, cosine of the second, plus sine of the second, cosine of the first. Sine of A, 4/5. Cosine of B, -5 over 13. Sine of B, -12 over 13. Cosine of A. Nice. Again, using today, something we learned before is drawing these triangles by location. -20 over 65 plus 36 over 65, 16 over 65. Nice. Tangent of the first plus tangent of the second over 1, sine is opposite, minus their product. Okay. Tangent of A is 4 over -3. Opposite over adjacent. Tangent of B is 12/5. Over 1 minus 4 over -3 times 12/5. Oh yeah. Oh yeah. Common denominator up here is going to be 15. So this is going to become negative 20 over 15 plus 36 over 15. This one's negative, this one's positive. 3 and 3, check. 5 and 5, check. Over. Here's a negative and here's a negative, so I'm gonna make that a plus. And this actually becomes 48 over 15. This would be 15 over 15. Oh, yeah, yeah, yeah. Yeah, yeah, 16 over 15 divided by 63 over 15. Did I make any mistakes yet? I hope the heck not.
No.
To divide is the same as multiplying by the reciprocals. The 15s would cancel. Final answer 16 over 63. Cool. That 3, 4, 5 was back to my Pythagorean triples over here. Don't get confused by that. One last problem. There it is. Verify. We're back to what we did the other day. I have to pick a side to work on it and go to town. Which side would you like to work on, left or right?
Left.
Left.
Yeah, left. And the first thing I'm actually gonna do is say, wait a minute, I don't mind radians so much, but I'm gonna make this the sine of 30 degrees plus S plus the cosine of 60 degrees plus S. You know, we like those a little, I like them a little better. Some of you may be good with radians, I prefer degrees. Okay, I'm gonna attack these, seeing if I can remember what both of them were. You know, I'm starting to use them and use them and use them. And hopefully you're doing homework right away this afternoon and you're using them because you'll remember them quicker. Sine of the first, cosine of the second, plus sine of the second, cosine of the first. Now for my second one. Cosine of the first, cosine of the second. Now it became a minus sine of the first, sine of the second. Woohoo! Almost ran out of room. Oh, where's that thought? Oh, I just tore that paper up and now I need it. Where was that paper? I need the sine of 30. Sine of 30 is 1/2. So this becomes 1/2 the cosine of S. All right, plus cosine of 30. Well, that's the square root of 3 over 2 sine of S. The sine of 60. Excuse me, the cosine of 60. What do I know for a fact from earlier? The cosine of 60 is going to be the same as the sine of 30. That becomes 1/2 the cosine of S minus the sine of 60. And sine is square root of 3 over 2 sine of theta. All right, so that's an equals to that side, equals because I'm verifying away. And let's see what I have. Oh, 1/2 a banana plus 1/2 of a banana.
Whole banana.
It is a whole banana, yeah. The square root of 3 over 2 sine S, negative the square root of 3 over 2 sine S. So long, farewell, auf Wiedersehen. Da-da-da. Yep. Just like that, it all comes out in the wash. All right. Any questions?